Consider an example where we have to transfer 1,000 books from one place to the other, from one room to the other room. Now there are various ways to do it, and there are three persons to do it. So now there are various ways to do this. Each one hands over the book, goes and places the other one book to the other room. Second way can be they all stand like a relay, and one person gives to the second person gives to the third person puts it in the other room. The third way is they get some bags, and then they put the books in the bags, and then they transfer it to the other room. Or they take few books together and then keep transferring to the other room. So now there are various ways to do one thing, and one way might be efficient than the other way. So when we try to analyze an algorithm, we are trying to analyze the algorithmic performance. And one method might take one time more than the other time. And in algorithm, we also check on the basis of space. Space complexity and time complexity. How much time does it take? How much space does it take? Here, one thing to note is space, it has gone very cheap these days, so space is not a major concern. What is always a concern is time. So time becomes very important when it comes to running the algorithm. With the help of this algorithmic analysis, we can also understand here how will my program behave for larger inputs. For smaller inputs, we can check, but how will my program react for larger inputs? If we run efficient algorithms, it will improve system performance. So efficiency of algorithms is judged on the basis of execution time and memory usage, and this will depend on what is the size of the input and the nature of the input. Nature of the input means it is an integer, floating point, or what kind of operations are these. If I run efficient algorithms, they will give me faster results using minimum of the resources. Whenever we try to judge the performance of an algorithm, we always give the notation in the form of n. What is this n? When we say O of n square, what is this n referring to? N is referring to the input size. Let's say if I have running a loop of 10, then 10 is my n over there. Running a loop of 200, then n is 200. And whenever we have an algorithm, we consider the best case, the average case, and the worst case scenario. Now the best case is running, let's say, some two inputs. Average case is running an average number of results, and worst case is running for a large number of inputs to check the result. So like this, we will be able to understand the complete behavior of an algorithm. We should analyze all the three cases, only then we will get the complete performance picture. So, when we talk about worst case analysis, it considers the maximum amount of time that the algorithm is going to need so that it is running under the most demanding conditions. Most demanding condition is large output. Best case analysis, it examines the scenario where the algorithms will run under the most favorable condition, that is small inputs, so that it will give me a good performance. And the average case analysis, it will consider all possible inputs, it will give me a balanced view. So each type of analysis is valuable depending upon the application. Now let us see about what do I mean by time complexity here. As I already told you, space complexity is not of a major concern, but time complexity remains a major concern. Here we are trying to understand, if I increase the number of input, how does my execution change? And here it's usually given in the notation like O of n, O of n square, and so on. So further we are going to see what algorithms come under O of n, what algorithms come under O of n square, and what algorithms come under O of log n.